Hi, this is Jacob Williamson with Technically Speaking at Source Allies. Today we're going to talk about Python context managers. So what is a Python context manager? If you've worked in other languages or frameworks such as React, a context manager might be a loaded term for you. In Python, a context manager is simply a block of code that has some defined entry and exit behavior. We can call this a context, and that's what they do. And this is useful if you want to make sure something happens on the start of a context and at the end of a context, or one or the other. To do this, it's fairly straightforward. Let's start with perhaps the canonical example of it. So let's say we want to open a file. So what you would do is you do file, open, and then just to be cheeky, I'm going to use this exact one just so we have some content in it. And I want to just print out all of that content. I'll do file, read lines, and then here's the tricky thing. With files, you're opening a resource. Now, for short programs, that's not going to matter all that much. The process will end and it will clean up all that memory for you. But for longer running processes, you don't want to just open resources without closing them. There have been production issues where if we had something running, it would open a file, read from it, do some processing, and attempt to close it. But it failed at closing it. And so what happened is we had hundreds of files open, and at some point the process has a quota that it reaches that you're no longer able to open files. And then in those production situations, you really just have to restart it. Not a great solution. So we want to make sure we close our file. So we'll close it. So now if we run this, we should see that it prints out in our entire file. And it does. It's not the prettiest thing in the world, but it is just a list of lines. So we have a defined entry, this open here, and a defined closing. I want to make sure that I always close. So what I can do is I can define a new object, call it open file. Oops, don't need you. So we're going to define our entry point. So this is double underscore enter double underscore, and it just takes itself as a parameter. This is going to be the behavior that happens when we actually enter our context. So here we want to open a file. Whoops. Here we go. We'll just give it our file again. And then we need to define our exit behavior. So a very similar method, double underscore and exit double underscore. And this takes some arguments. We'll get into that in a second. For now, we can just use our good old star args to get all of them. And then we want to close our file. Now, we don't immediately have our file, so we need to actually set it as a property on self. So that's pretty easy. And now we have our entry behavior, open file, and our exit behavior, close file. So now we can rewrite this down here to not use it, or to use, we can rewrite our behavior down here to reuse open file. And we do that with the with keyword. So with open file, we'll create a new instance, and then at like every block in Python, we have to give it an indentation. Then we can get rid of close. You notice we still have a problem though. We don't have this file. Well, there is an additional syntax with the keyword with. You can give it the as keyword as well. And so this is defining that open file, whatever the return of the enter method is, will be assigned to this variable right here. So I'll name it file. And like I said, it'll be the return of enter. All functions in Python implicitly return none. So as it stands now, this will be none, and we can prove that by trying to run it again. And we can see that the none type object has no attribute read lines. So we need to return our file. So really simple. We'll just return our file there. And now we should be able to see that we have our full file contents here. And it is, just to prove, it is calling both of these even though we're using just the with keyword. So we have our entering up at the top and our exiting at the bottom. Now, the nice thing about this is that even if you throw an exception, it will still run this closing functionality. So let's say instead of just printing, something goes wrong and I raise an exception here. So if I raise a value error, I don't know, whoops. If we run it again, we can see that it called entering. It printed out our stuff still because we were still printing our read lines. And then it called exiting. And so it closed our file, and then it threw the actual exception. So this is very useful if you want to actually do something with the exception. So let's say you want to actually catch it. If it's part of your domain, the value error is something you expect. You want to clean up the file resources, but then you also want to set some internal state. And that's where these actual arguments come into. So the arguments here, if we print them out, there we go, we can see that it exited with three things. The actual type of the error, so it's the value error, the error itself, we had a value error of whoops, and then a traceback object. And this traceback is literally the thing that's printed on screen. So let's say this is a domain error and you want to do something with it. You can now actually handle it. So you could access them through args, but I'm going to do exception type. They default to none, the exception itself, as well as the traceback. And so if you have an exception, so if exception, maybe you want to just say, we have an exception. I'll call it exception. So now when you actually hit it, you still have the exception, you still enter, you still print lines, and you still get called with exiting, or we got rid of exit, but it's still getting called. And now we're printing, we have this exception, and we're still throwing it. But what if you don't want to throw it? So what you do then is you return a truthy or falsy value from exit. So it will take the output of exit, and based on the truthiness of it, it will either propagate the error up or leave it be. So if you return true, so let's say return true here, we've handled this specific exception. It will no longer propagate upward. So if I call it again, it still gets called. We have an exception here, but it didn't actually throw it, and our program continues on as if nothing happened. Now, since we very specifically just said if exception is there, it'll catch all exceptions. And if you wanted to still have it throw, you would just either return a falsy object or nothing at all, because again, implicitly it will return none. So this is nice. It gives you fine-grained control, but you don't always need or really want that. There's a quicker method of doing this, and you can actually use a built-in library from ContextLib. There you go. Import Context Manager. Context Manager is a decorator. We have a video on that as well. Feel free to check that out. If you use the Context Manager and you say, I'll just call it open file. Not very Pythonic of me, but that's fine. And here we can do some setup. So we can do the same thing with print. We can then yield a value out of it. So yield, the keyword, will essentially, try not to use the same word in the definition, it will stop execution of this function, go to some other function, and then later come back to it. So you can yield out some value. So here we'll probably just do the value of open. So that's our actual file. We will set it to a value first. init.py, yield out our file. Whoops, that's not how you spell yield. Thank you. There we go. And then at the end, we will close it. And just like before, to prove to ourselves that it's working, we will print exiting. So very similar. Comment you out for now. If we run this, we should see, clear my screen, that it prints out entering, it prints out the same lines that we had before, and it prints exiting. You could as well have added in this parameter here, so like a file path. You could have done that on the class object as well in the init method. And this will allow you essentially the same thing as using the full class, but in a shorter way. What it doesn't give you, however, is our error handling in the same way. It will handle errors in a common sense way, but it won't actually do anything for you outside of that. So what I mean by that is if we call this now with this error, it won't actually call exiting. Because what happens is it raises this value error, it then gets sent into here. Once it actually unwinds the stack, it'll come back to the yield and realize that it's an error, and it will propagate it back up still. So then it won't actually ever close your file. What you would then need to do is actually do your own try catch. So you still have fine grained control of it, but it is through a more typical error handling pattern. So you can do a value error as E, print string the E. There we go. And so now if we call it, we can see entering, red lines, whoops, and exiting. So you have to handle your own errors in this case if you use the decorator. Now, this pattern is very useful for resources that, again, have a defined entering and exiting behavior or one of the two. So you'll see this a lot with resources. And you'll see it so often with resources that there's actually a built-in already for it. And if you know anything about Python, you probably have been wondering why I've even been talking about all this, because you can just do with open source init.py as file. Oops, I'm not going to throw an error. That would be silly. And the same thing has happened. We can see that our file is closed. You can double check that by going to File, Close, Close. There it is. So we can see that it closed the file for us. This has been Jacob speaking technically with Source Allies. Have a topic you want to see covered? Comment it down below. If you want to know more about Source Allies, check out our website in either the description or our profile. Thank you for watching. We'll see you next time.